and then we are done. Chalo. Inclined plane. You know inclined plane, just like the ramp that you have. Have you seen a ramp? Have you seen the aircraft luggage getting loaded in the aircraft? Have you seen the ramp is put out there? So those are inclined plane. Or if you go to IKEA, if you have come down without the stairs, then you have that travelator. Travelator is actually straight, which you have in airports. Inclined plane comes down. Okay, I'll just draw. This is also a simple machine. So our topic is inclined plane. Very quickly, we will do it very, very quickly. So inclined plane. And this is also used as, the inclined plane will work as a force multiplier because it will also reduce your effort. So actually, patients in a hospital are taken through the ramp. That's an inclined plane. So let's see how the setup of an inclined plane happens and what is the comparative advantage that you get over other things. Okay. So let's say, let me draw one. Say, there are two surfaces. Okay. This is one surface and this is the other surface. Let's say this is our ground level. This is the ground level. And let me put a load on this. Okay. Let me put a load on this. So let there be a load. This is a load on the ground level. The load is such that the mass of the load is equal to how much beta? M kg. M. The mass is M. And the height through which you are actually wanting to raise this load, you want to raise it through this height, and this height is h. This is my height, and this height is h. Understood? Now suppose you have no other option but you have to raise this item up. So how much of work are we doing? Means if we want to bring this object right up, right? So let's say this object, sorry. So this object is being brought at this level. All right. So the same object has been lifted. So you tell me how much of work are you doing here? The work that you are doing here is equal to mgh, because mg is the force. Mg force acts downwards. So you have to apply your force. So if you, that's again going back to your grade 9 class, your work classes itself. So it's something like this. The force acting downwards is how much? The force acting downwards is the weight, which is given by mg. So you have to apply your force equivalent to that. So the force that you are applying is given by F, and you have to move through a distance of height. So your work done actually was F multiplied by height, and F is nothing but mg. mgh. Have you understood? Right. Let's see option 2. In option 2, what we are trying to do, we have created an inclined plane. Say this much is an inclined plane that I have created. Clear? And I bring my object now and I place it on this inclined plane. So this is my object, all right? And we place our object on the object. We place our object on the inclined plane like this, all right? And the object has to climb how much? The object has to climb. Ultimately, you are putting it up at that height, but you are now using this particular route, right? So let's see your force diagram now. Now you will be pulling this object through a force on this side. Do you agree or not? This is the force with which you will be pulling the object. Who is applying? You are applying. So in the language of machines, can I not call it as my effort now? This is the effort which I am putting, right? And this effort is pulled over a length. Let this plane length be equal to, say, L1. L1 is the length. You're putting E over L1. Now just see what is the work done. Work done is force into displacement. Now don't bring cos theta out here, because in those examples, the displacement happened in this direction. Now displacement and force are all in the same direction. So how much is the work you are doing out here? The work that you do out here is given by E L dash. E is the force. E means E is your effort. E is your effort. and L dash is the length L1. Sorry, not L dash. It will be L1 because that's what we have assumed. So E into L1. This much you have pulled it. In the next iteration, what we are trying to do, in the next iteration, we are increasing our inclined plane length. Okay. So let's just see, and let's say this is my object, and right, this is my object, and now I am pulling it over an inclined plane whose length is equal to L2. Okay, and let's say you're giving an effort, same effort, say, or say, let's say your effort was E1 out here. Here your effort is E1. So let's say we see this effort. Here our effort is your effort is E2. The effort we are giving here is E2. So how much work are you doing out here? The work done here is given by how much? E2 L2. Is this much understood? In all the, so this is our case 1, this is case 2, and this is case 3. You yourself tell, where will your effort be less, you feel? Case 3 becomes very easy, but in case 3 we have to maneuver a much more length. If your effort is less in case 3, that means case 3 is a perfect example of a force multiplier. It should be a force multiplier, means mechanical advantage should be more than 1. Yes or no? What is mechanical advantage? It is given by load upon effort. तो पढ़े तो हो नहीं last week भी जो class हुआ, तो मैं याद दिला रहा हूँ. Mechanical advantage is load upon effort, right? So let's see what is the energy that once the box comes here. In all the 3 cases, the box will be coming up to this place, right? The box will be stacked up at this place. Box will be ultimately stacked up here. Box will be ultimately stacked up here. So don't you think the energy that the box has here is again mgh? Here also the energy is equal to mgh. Clear? Let's see, just for any case, let's say for L1, E multiplied by L1 is equal to how much, beta? mgh. Or rather, let me write it like this, same thing. I am writing mgh should be equal to E multiplied by L1. Do you agree or not? Mg is nothing but your load. So I can write the load is equal to mg, which is the weight. So I can write LH is equal to E upon L1. Right? No issues? So I now bring L upon E, and L upon E is nothing but the mechanical advantage, which is equal to how much? L1 upon H. Now this is a very stylish equation. Just see this. If you want your mechanical advantage to be more than 1, then only your job will become easy. Do you agree or not? Mechanical advantage more than 1 means if your MA is greater than 1, then the case is that of a force multiplier. And whenever you come to a force multiplier, your face becomes happy because you know that the effort will be less than the load. Now for this MA to be greater than 1, this ratio should be greater than 1. You forget this side. You have no control because you have no control on the load that you are lifting. How to make this greater than 1? If L1 is greater than H, for MA to be greater than 1, L1 upon H should also be greater than 1. Yes or no? That means L1 should be greater than H. Have you understood? Now let's see the 2 relations. This is also, here also you have a force multiplier, case number 2, and case number 3 also you have a force multiplier. Both are force multiplier. But if you see the mechanical advantage over here, that is MA1, MA2, case for MA2, in MA2 we are getting our mechanical advantages L1 upon H, and here in MA3 our mechanical advantage is L2 upon H. Now if you compare these two, you can say L2 is greater than L1. Yes or no? L2 is much greater than L1. Therefore L2 upon H will be greater than, sorry, L3 it's L2 only, sorry. So L2 upon H is greater than L1 upon H because they are being divided by the same thing. So you can say that the mechanical advantage in the third case is much greater than the mechanical advantage on the second case, which actually tells you that if you increase the ramp length, the mechanical advantage improves. Your effort will go on reducing, but the only thing is that you have to travel a greater distance. So if you create a ramp, so if you see in hospitals the ramp won't be very steep. They will be less steep, but they will be spread over a long distance. We don't mind walking more, or we don't mind pushing the patient more, but it should be easy to move the patient. Understood? This is all about inclined plane. And now you can do all type of problems. If an inclined plane is, they will tell you that a body has got a mass of blah blah, and it has to be lifted through a height of so and so, and the person has designed an inclined plane of length so and so. You can then ask, inclined plane, once you have made an inclined plane, it is a force multiplier. Then they can ask you, calculate mechanical advantage of the system. However, his friends suggest that if you reduce the inclination and increase the length, the mechanical advantage should improve. Can you justify? Or they can give you that the length has changed from L1 to L2, say from 10 centimeters to 15 centimeters. What is the net gain in mechanical advantage? So the mechanical advantage will also improve. Have you understood what I have tried to say? An object has to be ultimately, there is a truck out here. The truck's lorry or the carriage platform is at a height from the ground, and this box has to be loaded to the truck. Your first option is that you straightaway lift and load it. But if you do that, you will be giving much more of effort. There is no mechanical advantage. One way you can make it easy is by having a pulley. A pulley's mechanical advantage is 1, but it only makes the job a little bit easier considering the direction in which you are applying the effort. But if you see, when you create an inclined plane, creation of an inclined plane immediately makes the mechanical advantage more than 1. To increase the mechanical advantage more, what you can do is that you increase the length. In this way, your ratio of L upon H increases further. And more is the ratio of L upon H, more is the mechanical advantage. So with less effort, you will be able to lift it. We don't actually talk in terms of load and effort here. We reduce the load and effort ratio in terms of L and H. So you can draw this. This was all that I wanted to tell you about inclined plane. Yeah, 15 minutes. I know my job. 15 minutes. ठीक है, बना लीजिए सुंदर से. इसके बाद we will disconnect this and then we will go to our factorization वाला problem पे. ठीक है? Any questions on inclined plane? And your only thing left is levers now. So on Sunday morning, first we will have a theory discussion on levers, and then we will go for anything that is pending from factorization. Anyways, today we are on our last formula of factorization. नहीं, this is RS Agarwal, Bittu. Yo. ठीक है, चल रहा है ना बेटा अभी? Right, I'm disconnecting the video.